Hi guys, this is a video that is just going to kind of review and go over prime factorization. We talked about this back in Unit 1, and we went over it for a few days, but I think it's a skill that a lot of us kind of forgot or just aren't super comfortable with, so I just wanted to make sure that I made a video for you guys to watch just to kind of review it and the rules and how it works. All right. So prime factorization is breaking down a composite number until all of its factors are prime. And remember, a composite number is a positive integer with more than two factors. So it's a number that has more than two factors, okay? So a prime number only has one in itself. A composite has more than those two factors of one in itself. So you can use a factor string or factor tree to solve for prime factorization. So on the left here, over on this side, I did a factor string. So for 20, you'd have 2 and 20 would be a pair, 4 and 5 would be a pair, and then I could break 4 down into 2 and 2 and 5, and those would be all the pairs. So this, the 2 by 2, 2 times 2 times 5, would be my prime factorization, because prime, all the numbers are prime, and factorization are the factors. So all the prime factors, that would equal 20. Over here, I did the factor tree. And remember, think of this as the star on the top and then the tree comes down. All right, so 20, I did 5 and 4, so you have to start with a factor. 5 times 4, you could do 2 and 10. It doesn't really matter which two numbers you choose, you just can't use 1, okay? You cannot use 1 as a factor is a really big thing to remember, that you cannot use 1 as a factor. So I chose 5 and 4, and then with 5 and 4, I knew 5 was a prime number, so I circled it. So I know I'm done with that number. 4, I know I can break down into 2 times 2. So I did that, and then I know 2 is prime, so I circled those. So if you notice, I got the same answer for both the factor string and the factor tree. 5 times 2 times 2, and the order doesn't matter. So over here it says 5 times 2 times 2 if I read left to right, and over here it says 2 times 2 times 5. It doesn't matter which order you have them in, they'll all equal the same, because when I multiply this together, 5 times 2 is 10, times 2 is 20. So you always want your prime factorization to equal whichever number you are trying, that you start with, that you're breaking apart. So looking at the number 12, using factor string, 2 times 6, 3 times 4, 5 times nothing, and then 4 is my turnaround. So my prime factorization would be 3, and then I broke the 4 down into 2 times 2. So my prime factorization for 12 would be 3 times 2 times 2. If I used a factor tree, remember the start at the top, and then it comes down, I used 4 times 3. You could use 6 times 2 if you wanted. I broke the 4 into 2 times 2, and I know 3 is prime. So I end up, again, with that same exact answer. For 18, I did factor strings over here. 2 times 9, 3 times 6. I broke the 3 apart, or the 6 apart, into 3 times 2. So I ended up with 3 times 3 times 2. Okay? Factor tree, I did 9 times 2. You could do 6 times 3. And then I broke the 9 apart into 3 and 3. So I ended up with 3 times 3 times 2. So the same answer. If you want to shorten your answer up, you can use exponents. And remember, exponents are just those little numbers that tell us how many times the base, or the larger number, is written down. So 3 squared means that there are 2 3s times 2. Okay? And when you're doing prime factorization, you don't have to know both factor strings and factor trees. You can just choose one or the other, whichever one makes the most sense to you. Most kids will go to factor trees because it seems like a little bit less work, but it really doesn't matter to me which you use. If we look at 72, I just broke it down by steps. First step, pick a set of factors. So 72, I chose 9 and 8. Okay, second step, break down each number until you have only prime numbers. Well, I know 9 can be broken down into 3 and 3. So I can circle them, highlight them, just know that I'm done with them. I broke down 8 into 4 and 2. 2 is prime, so I highlighted it. And 4, I know I can break down into 2 and 2. So that leaves me with 3 times 3 times 2 times 2 times 2. Or 3 squared, because I have 2 of them, and 2 to the third, because I have 3 of them. Your final step, which a lot of you missed out on, and when we did the unit, was write your prime factorization as a multiplication problem. So those little dots that I have between are actually multiplication symbols. It's just easier for me to just do the dots. Okay? So that, when it says write the prime factorization in your math boxes, this is what they're looking for, or using the exponents. They aren't looking for this part up here. even though you need to use that to solve for it, but this isn't your answer. Your answer is this part down here, okay? I'm going to use 6 times 6. I'm going to break the 6 apart into 3 times 2. And what I know about 3 is that it's prime, and what I know about 2 is that it's prime. Well, if I did 3 times 2 over here for 6, I'm going to do the same thing over here. And that leaves me with 3 times 2 times 3 times 2. Or, if I want to use exponents, 3 squared, because there's 2 of them, 2 squared, because there's 2 of them. One more example, 48. I know 6 and 8 went on a date and their bill is 48, so I'm going to use 6 and 8 as my factors. I know 6 can be broken down into 3 and 2, and I know 3 is prime and 2 is also prime. I'm going to break 8 down into 4 times 2. I know 2 is prime. I know 4 can be broken down into 2 times 2, and I know 2 is prime. So my prime factorization for this would be 3 times 2 times 2 times 2 times 2. Okay, it got a little confusing, so I crossed out as I went. So I have 1, 3, and 2 is a base, and there's 4 of them. So either one of these answers would be correct, whichever makes the most sense to you. Okay, so the biggest thing to remember for prime factorization is choose if you want to use factor strings or factor trees. If you're using factor strings, I can't go back, it won't let me, but if you choose factor strings, so if you did 48, you could do, 2 times 24, I know, so you list all the factors that you know. And if you choose to use factor trees, you just have to make sure that you start with a pair of the factors that match up with the number that you're using, okay? It's the biggest thing a lot of kids messed up, okay? Let me know if you have questions. Rewind, rewatch, pause, make sure that you understand. Use this to help you, all right? Have a great night, guys.